Okay, grade 8. So from now until the end of the school year, we're going to be finishing chapter 9. Okay, so up until now, you learned all about quadratic functions, you learned about the characteristics of quadratic functions, you learned how to graph quadratic functions, okay? And the chapter before that, you learned how to factor. So now this is kind of bringing all of those skills together. And in 9.5 through 9.9, we're going to learn different ways to solve quadratic equations. Okay, so when we solve a quadratic equation, we're finding the zeros of that function. And what that means is if I have a coordinate plane, right, that looks like this. Okay, I'm trying to solve that quadratic equation, right? Say I have a parabola that opens like this. I'm trying to find the value, right, of the zeros on the x-axis, of where this parabola intersects the x-axis. And we talked about this. You could have two solutions, right? If my parabola looked like this and landed on the x-axis, right, if the vertex landed on the x-axis, I could have one solution. Or say my parabola was way up here, I could have no solutions. Okay? So we're going to learn different strategies for finding the zeros of a function or for solving the quadratic equation. Okay, so I'm going to start off with example 1. I think the easiest way to teach this section is just to walk you right through it. So we're going to solve quadratic equations by graphing in this section. We're only going to do this section today, you guys. You're going to do some practice problems, and then we're going to move on to 9.6 tomorrow, because this actually is not the most accurate way to find the zeros of a function or to solve a quadratic equation. So I wouldn't use this graphing strategy unless I had a graphing calculator. That's like the only sure way to be able to tell the solutions using this method. So anyways, what I want you to note on page 622 is that there's a know it note, and there are 3 steps for solving quadratic equations by graphing. I want you to write those down, okay? So it's right here. See it? All right, so page 622, you're going to write down those 3 steps. So solve quadratic equations by graphing. Step 1, you're going to write the related function. Step 2, graph the related function. Step 3, find the zeros of the related function. Okay, so if you need to, you can pause and copy that down. Okay, good. Something else I want you to notice, all right? So example 1, it says solve each equation by graphing the related function. So here we have 2x squared minus 2 equals 0. Okay, the first thing we need to do, you guys, is change this 0 here to a y value. Okay, so now if I were to rewrite this, I would have y equals 2x squared minus 2, right? If 2x squared minus 2 equals y, then we can just rewrite that and put y in front. So I rewrite this as y equals 2x squared minus 2. Great, so this is the related function to my original one, which was 2x squared minus 2 equals 0. Okay, so now this is what I'm going to be graphing. All right, so now we're going to graph the function. All right, so we're going to use those steps, right? So step 1, we wrote the related function. Step 2, graph the function. Example 1 on page 622 breaks down how to graph this, okay? So you're going to use the skills from the last chapter. So step 1, we're going to find the axis of symmetry, right? What did we say the axis of symmetry was? X equals negative b over 2a, right? So again, I'm going to identify a, b, and c up here. All right, so if I were to rewrite this in standard form, okay, if I were to rewrite this in standard form, we have 2x squared. I don't have a single x here, so that's 0x, and then I have negative 2. Okay, so my a value is 2, my b value is 0, and my c value is negative 2. So when I rewrite this axis of symmetry problem here, I'm substituting 0 for b, okay, and I can actually kind of stop there, and then 2 for a, so 2 times 2 is 4. 0 divided by 4 is just going to give me 0, so my axis of symmetry for this is x equals 0. Okay, now I take x, I need to come up with a vertex, right? So my vertex is going to be xy, it's a coordinate. My x coordinate is 0. I need to substitute 0 for x up here to find y. Okay, so when I do that, 0 squared is 0, 0 times 2 is 0, 0 minus 2 gives me negative 2 for y. So my vertex is 0, negative 2. Okay, and then I need to find what? 2 other points? 2 other points along the same side as the axis of symmetry. So if my vertex is at 0, negative 2, I'm right on the y-axis, so I'm just going to pick 2 points to the right. All right, left or right doesn't really matter in this instance. So I'm going to find my x value as 1, and then my other x value as 2. And again, you guys, I'm just substituting to solve. We already did this, okay? So I take 1, and I replace x up here. What's 1 squared? 1. 1 times 2 is 2. 2 minus 2 is 0. So my y-coordinate is 0, and I do it again with 2. So I substitute 2 for x. What's 2 squared? 4. 4 times 2, 8. 8 minus 2, 6. Okay, so now I'm going to take this information and graph it. Alright, so you're going to take out your graph paper or your coordinate planes, which I attached for you. So if you don't have them, you can print them up, okay, or you could just make your own if you need to. But either way, the first thing I'm going to do is plot my axis of symmetry. My axis of symmetry is just x equals 0, so it's going to be along my y-axis here. Straight down. Axis of symmetry, okay? Then my vertex is 0, negative 2. So 0, negative 2, I stay at 0 for x, and then I go down 2. There. Then I'm going to plot my 2 other points. So I have 1, 0, and I have 2, 6. So over 2, up 6. 1, 2, 3, 4, 5, 6, right here. Okay? Now I need to take these 2 points and reflect them over the axis of symmetry. So here, right, I have my vertexes on 0, negative 2, so I'm going to come up to this point. This is 1 to the right of the axis of symmetry, so I'm going to plot my other point 1 to the left. Remember, your axis of symmetry gives you a mirror image. Then I come up to this point. Okay, this is 2 to the right, so I'm going to plot 2 to the left, which lands me here. And now I'm just going to connect this with a smooth curve. Okay? We're not done yet now. We need to identify, we're trying to solve. The original problem said solve each equation by graphing. So now that I graph my parabola, okay, I'm going to look here. I have exact zeros here, so this one works out good, right? I have a solution here, and I have a solution here. So my 2 solutions for this, the zeros appear to be at what? Negative 1 and 1. So my solutions are negative 1 and 1 for this equation. The tricky part is, if we don't land on an exact coordinate, you guys, what if like I had a 0 here? What if I had another parabola that looked like this? Okay. If I had another parabola that looked like this. Alright, I can't tell what that point is. I think it's like negative 2.5 maybe, but I can't get an exact answer. And same with this one. Like, what is that? Maybe that's 1, 2, 3.25 maybe? I don't know. So the problem with this method is that if it doesn't land on an exact coordinate, you have to guess. So I'm going to just let you guys circle these, okay, and that will be your answer, and you're going to give me an approximate answer if that were your answer. So this would be about 2.5, say, and this one would be about 1, 2, 3, say 3.5, okay? But that's why this method isn't always the best method to use. First of all, it takes a long time, and you don't always get an exact solution. Okay, top of page 623, we're doing the same thing. We're solving this quadratic equation by graphing. So the first thing I'm going to do is take the 0 and change it to a y. Okay, and then I'm actually going to take the y and just put it to the front. So now I have y equals negative x squared minus 4x minus 4. My a value here equals negative 1. My b value is negative 4, and my c value is negative 4. Okay, so my next step then is to come up with the axis of symmetry, right? Axis of symmetry, the vertex, and then, oh, the y-intercept. I think I skipped that on the last one. Y-intercept. Okay, and then 2 other points. 2 other points. All right, so again, axis of symmetry is negative b over 2a. When you solve that for this one, you get x equals negative 2, okay? And then you substitute negative 2 in for x to then get your y coordinate. So your y coordinate here is 0 for the vertex. So your vertex is negative 2, 0. Your y-intercept is your c value. That's negative 4. So it's going to be 0, negative 4, right? If it's a y-intercept, we replace y with negative 4, x is 0. And then the two other points that we're going to come up with, they actually only picked 1 point, so we're just going to do negative 1. So when you substitute negative 1 in for x, you get negative 1. Okay, now we're going to take this information and graph it. Okay, so when we graph the axis of symmetry, it's x equals negative 2. So I find negative 2 along my x-axis is here. Okay, this is my axis of symmetry. This is my line of reflection, which I would end up erasing after the fact. My vertex is negative 2, 0. So that puts me here. My y-intercept is 0, negative 4. Which lands me here. And my other point that I'm going to plot is negative 1, negative 1. So I go back 1, down 1, which lands me here. Okay, now I'm going to reflect my points. So here, if this is my axis of symmetry, I went 1 to the right, so now I go 1 to the left. Down here, I went 2 to the right, so now I have to go 2 to the left. And I'm going to connect this with a smooth curve. Okay, you can erase this axis of symmetry if you want. But look at here, you guys. As soon as I see that the vertex lies on the x-axis, I know that that's my only possible solution. So my only solution here is what? If I look across my x-axis, it's negative 2. So negative 2 is my only solution, you guys. As soon as I saw that my vertex is negative 2, 0, you can pretty much stop there and know that that's your only solution. So my answer for this one is negative 2. Okay, so our last example is C, and that says, again, we're solving the quadratic equation by graphing, okay? So we have x squared plus 5 equals 4x. Listen, I want to get both of these terms over to the other side. I need to put this into standard form. So this is going to go to the other side, and this is going to go to the other side, and we switch our signs. So if this is my equal sign, x squared jumps the wall, it becomes negative x squared. Positive 4x is already on this side, so that stays the same, and positive 5 jumps the equation sign and becomes negative 5, right? What we're doing is adding its opposite to both sides. Cancels on this side, goes to the other side. Now I'm in standard form. I need something here, right? That would be 0, but we're going to replace 0 now with y because we're solving a function. Okay, my a value is negative 1, b is positive 4, and c is negative 5. Okay, so when you look at example C, all right, they're telling you to graph it using a graphing calculator, which you can do, okay? But either way, if you find the axis of symmetry, the vertex, the y-intercept, right, and you plot this, okay, you're going to notice that the vertex here is 2, 1, all right? If I look across my x-axis, okay, this parabola never intersects the x-axis, right? It's going in a upward direction here, see it? All right, and it's never going to pass my x-axis. Therefore, my solutions are no real number solutions. So I would write no real solutions for my answer because it doesn't intersect the x-axis. So this one can't be solved. It's just no real solutions. All right, so I hope this video helped you. Okay, and the last one is example 2. It's just like a real world problem. It says a dolphin jumps out of the water. All right, so I'll put this up here. It says the dolphin jumps out of the water. The quadratic function y equals negative 16x squared plus 20x models the dolphin's height above the water after x seconds. About how long is the dolphin out of the water? All right, so to do this, you're just solving for the 0, guys. So we change y to 0. Okay, or I'm sorry, 0 to y, right? And then you graph the function. And when you graph it, you see that if the dolphin jumped out of the water, he started at 0. He jumps out of the water, and then when he lands, the point that this parabola here intersects the x-axis, that tells you how long he was in the air for, right? If he leaves and then arches and then lands. This solution tells you, right? So one solution 0, but that's obviously not it because that's when he, right, left the air. And this